The diverging grades, a quantitative study. Statement of the problem. Parenting relationships are among the most important in a youth's life. The quality and strength of the parenting bond influence the quality of how the teen will treat other people. Hypothesis. The researchers wish to test the proportion that students do not tell their parents their grades unless they are asked to. The null hypothesis of this study is population is greater than or equal to 0.56, which states the proportion of students from Pascal who tend not to tell their grades to their parents. While the alternative hypothesis of this study is population is lesser than 0.56, which states that the proportion of the student from Edison who prefers not to tell their grades to their parents are lesser than the proportion of students from Pascal who also doesn't like to tell their parents their grades in school. Participants. Our participants are the senior high school students of Malayan Colleges, Mindanao. 36 students are from the section of Pascal. 36 participants will be coming from section Edison. Data. The researchers have a total of 36 respondents per section. The researchers surveyed the students in section Pascal and Edison whether they tell their parents about their grades or not. In section Pascal, 19 students agreed that they do not constantly tell their parents about their grades. Procedures for testing hypothesis using p-value. Step 1. State the null and alternative hypothesis. The null hypothesis is p greater than or equal to 56, while the alternative hypothesis is p lesser than 50. Step 2. Select a level of significance. The level of significance to be used to perform the hypothesis test is at a is equals to 0.05. Step 3. Select the test statistics. So NP hat is equal to 36 times 0.56 is equals to 20.16 greater than or equal to 5. NQ hot is equal to 46 times 0.44 is equal to 15.84 greater than or equal. Since NP hot and NQ hot is greater than or equal to 5, the sample is large enough so the test statistics is Z is equals to X minus NP hot over square root of N P hot times Q hot. Step 4. Formulate the decision rule. Since the test is one-tailed, the critical value is the Z value that gives value of 0.05 to the right. Therefore, we reject null hypothesis if Z is less than Z base 0.05 is equals to 1.645. Step 5. Compute the value of the test statistic. Compute the p-value of the test statistics and substitute this value. P hat is equals to 0.56, Q hat is equals to 0.44, N is equals to 36, and X is equals to 23, in Z is equals to X minus N P hat over square root of N P hat times Q hat. So, equal to 23 minus 36 times 0.56 over square root of 36 times 0.56 times 0.44 almost equal to 0.95. Step 6. Make decision. Since the computed value 0.95 is lesser than 1.645, the null hypothesis is failed to be rejected.